So let's say I have a complex number z, okay, which is equal to a plus what? ib, okay, where a and b are what? Real numbers, and then this I here is what? It's an imaginary number. So with the z here, we consider the a to be the real part, and then the I multiplying b is what? The imaginary part. So with this z here, we can write z as what? Z equals what? A comma b. Okay, where the component of z may be considered as what? The coordinate of what? Of a plot. So what that means is that you can plot z on the graph. Okay, so I have the graph here. So with this graph, you are going to name this the real axis. Okay, the real axis or the positive x. Okay, and then you name this side here imaginary axis. Okay, or the positive y. This side is the negative x axis, and then this is the what? The negative y axis. So with this plot here, okay, with this graph here, you can plot z here. Okay, so let's say I have this point to be a, and then I have this point to be b. Okay, so you can plot z here. Okay, so this is the plot of what? Z. So that's what this means. So you are considering the components of z, which is a and b, to be what? The coordinates of what? Of a plot. So we call this diagram here what? The Gantt diagram. So let's learn more about this. So when you look at it, the distance from the origin here to the point of plot of z, okay, this distance here is known as what? The modulus of what? Z. This distance is known as what? The modulus of what? Z. Normally represented with the symbol, the absolute value of what? Z. Okay, this is what? The modulus of what? Z, which is the distance from the origin here to the point of what? Plot of the complex number of Z. So when you look at this line here, which is the modulus, okay, it makes an angle with the positive x axis. Okay, it makes an angle with what? The positive x axis. So let's name this angle theta. Okay, and this angle theta here is known as what? The argument of what? The complex number z. Okay, it's known as what? The argument. The argument of the complex number of z, written in the short form as what? As z. Okay, so that's the argument of what? The complex number z. Okay, so looking at this, okay, we can draw a triangle from what I have here. Okay, we can draw a triangle here. Okay, so let's say we have this triangle. Okay, let's say we have this triangle here. So this triangle, we have this side to be A, and then we have this side to what? To the B, to be the what? To be the B. Okay, so let's say I want to find this distance here, which is what? The modulus. How am I going to do that? So I'm going to apply Pythagoras theorem here. Okay, so you know this is the longest side, which is the hypotenuse, and that's the what? The modulus. So that's what? The modulus squared. Okay, equal to what? The square of the other two values. That's a squared plus what? B squared. Okay, so I'm going to squared and then add the values of what? The other two uh, components. Okay, so you squared A and then you squared B, then you added them. So that's what Pythagoras theorem. But here you want to find what? The modulus of what? The complex number z, which is what? This absolute value of z that we've written here. Okay, but it is raised to the power 2. So we have to get rid of this. So to get rid of this, I'm going to raise both sides to the power what? 1 over 2. Okay, so that's what? Mod z, okay, to the power 2, all to the power what? 1 over 2. Okay, so this will be equal to what? A plus B. Okay, B squared to the power what? 1 over 2. So when I do this, these two will cancel out these two. Okay, so at the end, I'll have what? The modulus to be equal to what? A squared plus what? B squared to the power what? 1 over 2. Okay, and then we can write this as what? The modulus The modulus equals what? The square root of what? A squared plus what? B squared. So this is the formula that we will use to calculate for the what? For the modulus of what? Any complex number. So let's have this written down. So let's look at how you are going to calculate for the what? Argument. Okay. Let's look at how you are going to calculate for the what? Argument of what? Of a complex number. So the argument is the angle that the complex number makes with the what? With the positive x axis. Okay. So looking at this complex number z here, the angle that it makes with the positive x axis is what? This angle what? Theta here. Okay. That's from the positive x axis to what? To where the modulus is. Okay. So that's the argument. So how can you calculate for this argument? So to calculate for this argument, we take the tan of the angle theta. Okay, tan of theta. This will be equal to what? Opposite. Okay, over adjacent. Okay, that's what? Opposite over what? Adjacent. In this case, the value opposite to the angle theta is what? B. So that's what? B over what? The adjacent, which is what? A. So if you want to find this angle theta, which is the argument, that what? Theta will be equal to what? The tan inverse of what? B over what? Over A. So that what? The angle theta. And this angle theta will be the what? The argument of what? Z. Okay, so you see that what? Therefore, the argument of Z equals what? The tan inverse of what? B over what? A. So that what? The argument of what? The complex number what? Z. It's very, very simple. So let's take some examples to help us understand this better. So now let's consider the complex number Z, which is equal to what? 3 plus what? 4i. Okay, so you have to calculate for the what? The modulus and then the argument of what? This complex number. But before we do that, let's draw the plot, okay, or the graph for this complex number. So you see that what? This complex number is in the first quadrant here. Okay, so let's take this side to be 3, and then this side to what? To what? The 4. And then this is the real axis, and then this is the what? Imaginary axis. Okay, so we can write z as what? 3 comma what? 4. So let's after plotting z, okay, we got z to be here. Okay, so now let's draw the line here from the origin to the plot. Okay, so you have z here to be what? 3 and then 4. Okay, so now let's calculate for the angle it makes with what? The positive x axis and then the modulus. So this angle is the what? The what? Is the argument, and then the modulus is this distance from the origin to the point of plot. Okay, so this is what? The modulus. So I have to calculate for these two values here. Okay, so we can use Pythagoras theorem to calculate for the what? For the modulus, and then you got the general formula to what? The modulus equals what? Square root of what? A squared plus what? B squared. Okay, so that will be modulus equals what? Square root of what? A. A in this case is what? 3 squared, and then plus B squared, which is what? 4 squared. Okay, so let's see the value of this. Okay, so this will give us 5. Okay, so therefore you have what? The modulus of the complex number z to be equal to what? To be equal to what? To 5. Okay, so now that we know the modulus, let's calculate for the argument. Okay, so I'm going to calculate the argument. So for the argument, we can use the formula tan theta, okay, equals what? The opposite of what? The adjacent. And you know the opposite is this 4 here. Okay, this 4 here will be the opposite, because when you draw this, we have what? 4 here, and then we have what? 3 here. Okay, so the opposite is what? 4. That's the value opposite to the angle theta is what? 4. So opposite over what? Adjacent. That's what? 4 over 3. So we will have what? The angle theta to be equal to what? Tan inverse of what? 4 over what? 3. So let's see the value of that. So that will give me the angle theta to be equal to what? 53.13 degrees. Okay. So this angle theta here, okay, it is that same angle that the this line here makes it what? The positive x axis. So you consider this angle theta to be what? The argument of what? Z. So therefore, the argument of the complex number z will be equal to what? 53.13 degrees. Okay. So if you don't want to write the value of your argument in degrees, you can write it in what? In the radians form. Okay, so you can convert it from degrees to what? To radians. Okay. So you have to be very careful about that. Sometimes your calculator might be set to um, radians, and then you calculate for the complex number and to give you the value in radians, but you wouldn't know that it is in a radian mode. Okay, so you have to be careful with that. Okay, so in this case, I'm calculating for the value of my argument in what? In degrees. Okay, so we know the argument, and then we know what? The modulus for what? This complex number here. Okay, so now let's take another example. Okay, so let's consider the complex number z equals what? Minus 3 plus what? 4i. Okay, so you have this complex number here. So now let's draw the plot. Okay, so you have this to be the real axis, and then you have this to be the imaginary axis. Okay, so when you plot this, let's rewrite z in components from that what? Minus 3 and then 4. Okay, so you have what? Minus 3 here, and then you have what? 4 here. Okay, so when you plot z, we have what? Z in the second quadrant. Okay, so you have what? Z in the second quadrant. Okay, so you have z here, minus 3 and 4. Okay, so this is z here. Okay, so now let's draw the line from the origin here to the point of what? Plot. Okay, alright, so the magnitude of this line is the what? Is the modulus. Okay, the magnitude of what? This line is the what? Is the modulus. Okay, so now let's calculate for the modulus. So for the modulus, you can use the formula z equals to the square root of what? A squared plus what? B squared. Okay, so that will be equal to what? The square root of, in this case, a is what? Minus 3. So that what? Minus 3 squared. Okay, plus b squared, which is what? 4 squared. Okay, so let's see what you get for this. So this will give us what? The value of what? 5. Okay, so this will give us what? The value of what? 5. So therefore we have what? The modulus of the complex number z to be equal to what? 5. So now that we know the modulus, let's calculate for the what? For the argument. So how are you going to do this? So the argument is the angle that what? This line here makes with what? The positive x axis. Okay, which is this axis here. Okay, positive x axis. Okay, this is what? Positive y. So you want to find the angle from this line here to the positive x axis. Okay, so let me indicate the angle. So you want to find this angle here. Okay, so this angle here will be the argument. Okay, this angle here will be what? The argument of what? The complex number what? Z, and not this angle here. So how are you going to do this? So there are two ways to do this. Okay, so now before you can calculate the angle from this side to this side, you can apply two methods here. You know that this side is what? 90 degrees. Okay, So you can calculate for the angle here, then you add it to what this 90 degrees here. Okay. And also we know that what the theta angle from this point here to this point is what 180. Okay. So you can calculate for the angle here. Okay. Let's name it angle C. Okay, you can calculate for this angle here and then subtract it from what 180. Then that'll give us what the argument for this complex number Z here. So let's look at each of these methods here. Okay, so first of all, I'm going to calculate for this angle here, which I'll name angle C. Okay, I'm going to calculate for this angle here. So with this angle, you have one component here. Okay, so to calculate for the angle C here, how are you going to do that? So let's use tan. Okay, so tan C. Okay, that's the angle C. Tan C will be equal to what? Opposite. So the opposite in this case is what? -3. Okay, but when you want to find for the angle, okay, you don't consider the signs. Okay, so if it is -3, you have to what? Ignore the sign here. So that what tan C will be equal to what? Opposite, which is what? 3 divided by the adjacent, which is what? 4. Okay, so C will be equal to what? The tan inverse of what? 3 over what? 4. So let's see what we get for that. Okay, so you got C to be what? Equal to what? 36 point. Let's make it 87 degrees. Okay, so that's the value of what? Angle C here. Okay, so the value of this angle C here, okay, we want to measure the angle from this point here to what? This point here. So what do? We already know that this point is what? 90 degrees, and we know this point is what? Angle C, which is what? 36 point what? 87 degrees. So therefore the total angle will be what? The sum of what? These two angles, and then that will give us what? The argument. So therefore the argument of the complex number Z will be equal to what? 90 degrees plus what? The angle what? C. Okay, so that will be equal to what? 90 degrees plus what? The 36.87 degrees. So let's see the value of that. So this will give us the argument to be equal to what? 126.87 degrees. So this will be the argument for this complex number Z here. Okay, so let's look at another way to find the argument. Okay, so to find this argument, let's say you want to use this angle here. Okay, so let me consider this angle here to be angle D. Okay, so you want to use this angle here. Okay, so when you use this angle here, we will subtract it from what? 180, and then that'll give us what? The argument. So using this angle, okay, using this angle here, okay, so the tan of the angle D, okay, will be equal to what? The opposite of what? The adjacent. So in this case, the opposite is what? Is 4. And then the adjacent is what? -3, but you don't consider the negative, so just write 3 here. So you have D to be equal to what? The tan inverse of what? 4 over what? 3. So let's see what you get for that. So this will give us the value of what? 53.13 degrees. So that's the value of what? D. Okay, so that's the value of what? D. This D here is not the argument, okay, of the complex number. It's just the value of what? The angle here. The actual argument for the complex number is what? The angle from this point here to what? This point here. But you know that what? The sum of the angles on a straight line is what? Equal to what? 180. Okay, it's equal to what? 180. And then we know this part is what? 53.13 degrees. So for us to find the remaining angle, we will subtract what? This angle DL from 180. So you have what? The argument of Z to be equal to what? 180 degrees minus what? The angle what? D. So that will be equal to what? 180 degrees minus what? Angle D, which is equal to what? 53.13 degrees. Now let's look at the answer for that. So that gives us the argument to be what? 26 point what 87 degrees. Okay, so you see that what with all these two methods we were able to what to solve for the what argument of what the complex number what z, which is equal to what negative 3 plus what 4i. But you see that what this method here, okay, using this method to find out the argument of what complex numbers is a bit tedious. Okay, so I'm going to teach you some simple way to calculate for what the argument of what complex numbers. Now let's look at how we are going to do that. So I write down the formulas down. Okay, so for the first quadrant, okay, for the first quadrant, that's the first quadrant. If you want to find the argument of a complex number, you use the formula as z, okay, equals what the tan inverse of what y over what x, okay, where y and x are considered as what the components of what the complex number. So let's say you have the complex number z to be equal to what x plus what iy. Okay, so x and y are the real parts, and this I is the what imaginary number. Okay, so x here is a real number, y here is also a real number, and then this I is what is an imaginary number. But when we multiply I with this y here, they all become what an imaginary number. So you have the x here to be the real part, and then iy here to be the imaginary part. So with this, if you want to find the argument of this complex number here, okay, that will be equal to the tan inverse of what y over x. That's what the first quadrant. Okay, so let's say if you want to find the argument of a complex number in the second quadrant, okay, you will use the formula as z equals what? As z equals 180, okay, minus what? The tan inverse of what? Y over what? X. Okay, so if you want to find for the argument of a complex number, okay, in the second quadrant, you are going to use this formula here. So let's say uh, if you want to calculate for the argument, okay, of a complex number in the third quadrant, okay, you're going to use the formula as z equals 180, okay, plus the tan inverse of what? Y over x. Tan inverse of what? Y over what? Over x. Okay, and then for the fourth quadrant, if you want to find for the argument, that was as z. Okay, as z will be equal to 360, okay, minus the tan inverse of what? Y over what? Over x. Okay, so when I'm doing this, let's say when the complex number was given, okay, we have what? 2 minus what? 3i. Okay, so therefore you know that what y is what minus 3, and then x is what? X is 2. So when you're fixing these values into these formulas here, okay, if any of the values what is negative, just ignore the sign, okay, change it to what? Positive. Okay, so if this 2 here is what is negative, and then you are putting it in this formula, you are going to make it what? Positive. And then this 3 here that's negative, you're also going to make it what? Positive. So with this example here, okay, with this example here, we got what? The argument to be what? 126 point what? 87 degrees. Okay, so now let's use these formulas here, okay, to calculate for the what? Argument of this complex number z here. So with this complex number z here, you see that what? It lies in the second quadrant. Okay, so which formula are you going to use? You're going to use this formula 180 minus what? Tan inverse of what? Y over x. So therefore you have what? Argument z to be equal to what? 180 minus what? The tan inverse of what? Y over x. Okay, and then you know y to be 4, and then x to be what? To be 3. Okay, so now let's simplify it. So this will give us what? 180 minus what? The tan inverse of what? 4 over 3. That will be equal to what? 100 and what? 26.869. So let's make it 87 what? Degrees. Very simple. So we see that what? When we use this formula, there was no need for us to what? To come and do all these computations that we did here. Okay, same way for the first question. Okay, so for the first question also, let's try these formulas for it. So for the first question, we had what? Z to be equal to what? 3 plus 4i. Okay, that's what we had. So that was the question. So with this, let's calculate for the what? The argument. So argument of z. So when you look at z, when you plot z, it will be in what? In the first quadrant. So we will use the formula tan inverse of what? Y over what? X. So that was tan inverse of y over what? X. Okay. And then we know that what? Y is what? 4. So that will equal to what? The tan inverse of what? 4. And then x is what? 3. So that was over 3. So this will be equal to, that give us a value of what? 53.1 degrees. Okay. That gives us a value of what? 53.1 degrees. Okay. So let's say you want your answers to be in the radians form. Okay, let's say you want your answers to be in the radians form. So let's look at how that is going to be. Okay, so if you want your answers to be in radians form, okay, it's that same formula, but we are converting the value of the argument into what? Radians form, not in degrees any longer. So let's look at how we are going to do this. So for the first quadrant, okay, for the first quadrant, we know that what? Pi equals what? 100 and what? 80. Okay, so therefore it's 1 over 2 pi equal to what? 90 degrees, and then 2 pi will equal to what? 360 degrees. So let's have this in mind. Okay, so for the first quadrant, considering the complex number z equals what? X plus what? Iy. Okay, the argument of z will be equal to what? The tan inverse of what? Y over what? Over x. Okay, so when you're doing this, you make sure that what? You change your calculator to what? To the radians form. Okay, so to do this, first press the shift button and then press the mode button. Then you choose the option 4. That will convert your calculator into what? Into radians. Okay, so now that this for the first quadrant. Okay, so for the second quadrant, okay, we are converting it into what? Radians. So you have what? The argument z will be equal to what? Pi. Okay, minus what? The tan inverse of what? Y over what? Over x. Okay, and the tan inverse of what? Y over x. So for the third quadrant, okay, you have what? The argument of z to equal to what? Pi plus the tan inverse of what? Y over what? Over x. Okay, and then for the fourth quadrant, you have what? The argument of z to be equal to what? 2 pi. Okay, minus what? The tan inverse of y over x. Okay, so if you want to get your answers in radians form, these are the formulas that you are going to use. Okay, but before then you have to make sure that your calculator is your calculator has been set to what? To radians, otherwise you get the answer wrong. Okay, so we will end this lesson here. So I'll give you a question to try. So let's try this. Okay, so find the modulus and then the argument of the complex number minus 3 minus what? 4i. Okay, you can write your answers in the comment section. Thank you very much for watching this video.